All right, our last lesson. So we're dealing with exponential logarithms. They're going to, you guys have already learned all the properties. All you're going to do now is pull from your bag, right? You're going to solve an equation, but you have tricks now. Let me show you what I mean. So can you tell me, is that answer, this is 6 to some power equals 10, is it a clean answer? No. Can you tell me what the answer is going to be between? 1 and 2, right? Because to the first power would be 6, to the second power would be 36. This is how we deal with it. I got 2 different ways. We can use this form, b to the power equals n, and switch it to p in the log bin. I can do that. I'm going to show you guys both. So let's do that method first. All right, so I'm just going to flip forms. What's my p? You see what they did right away? X equals. We got our solution. Okay, and then log. What's our base? 6, yeah. To the of 10. Now, your calculator, I don't know, depends on which one you're using. But most of them can't take that in and evaluate it. So we use that change of base formula, which is log of 10 over log of 6. It's just using the base 10 because I can use it in my calculator. So now you'll be able to use your calculator and plug that in. So log of 10 divided by, hold on, I don't think that parentheses there. Oh, it was. And divided by log of 6. I got 1.2851 if I round. Yep. You can always check this too, right? Take that. If you wanted to see if that was the right answer, you take your calculator and just do 6 to that power. It's 10. So you can always check. Sorry, I know that script is super little. All right. I don't usually take that method. I know it's easy, but this method only works sometimes. It has to be exactly in that form. It has to look exactly like it. So I'm going to show you the other way to go about it. I can do whatever I want to an equation as long as I do it on both sides, right? So I'm going to take a log, and since I'm calculator minded, I want to make sure that I'm either using base 10 or ln. So I'm going to take log. I don't use ln unless I have to, and I'll show you a later problem that will. I'm going to take a log of both sides. So I use this route instead of the one on the left. What can I do with that x? It was like properties from last week. If I have a power up there, anybody remember? You just pull it down. It just comes out front. It's the power rule. Do you guys remember seeing that last week? That we can take a power and we can just bring it down if there's a log. Solving for x. How do you solve from x from here? Yeah, how? How do we do it? Divide, yeah. So I'm going to divide both both number sides, getting it out there. And that's going to be, do you see that's the same one we just did? 1.2851. If you were to plug in, just so you can see it, move over. There we go. If I were to just plug that in, 6 to the power of 1.2851, is that going to give me 10? No, it's because it's rounded, right? But if you look at that number, that's 10, isn't it? It's a lot of zeros after, but that's just because you rounded pretty hard. Okay, so there are 2 methods to do it. The right side works every time. I like methods that I can rely on and not have to think about when I can use it and when I cannot. All right, this lesson, we're just going to take this idea and each next example, we're going to just make it a little more difficult. It'd be really great if I could make this problem look like the last problem because we know how to do it. So I really want to just get this 5 to the x power by itself. So everything around it I need to get rid of. What would you guys do first if it looks like this? Not yet. What would you do first? Yeah, subtract 1. We always want the same as before. Division should be like our last step. So we minus 1 from both sides. So I got 2x over here, 8. I'm just modeling on the left side, right? You don't need to write it down, but I'm just trying to use that to model what we do next. Now what?
Can you multiply the 2 and 5?
I'm glad you said that. No. That is the common error I see the most. I have my Calc 3 students that still do it. PIMDAS, right? Parentheses first. You can't do 2 times 5. But I could divide the 2 out. So I got 5 to the x equals 4. Where do you guys expect your answers to be? Your answer.
Less than 1.
Yeah.
Between 0 and 1.
Between 0 and 1, right? Because 0, 5 to the 0 is 1. 5 to the first is 5, so 4 is in between. So we know to expect that. So what we do is we take a log of both sides. I always just do base 10 because my calculator has it. Slow me down if I go too fast. We have plenty of time. I finished in 40 minutes earlier this morning. What would you do from here? Perfect. Perfect. So we got log 4 divided by log 5. And then we plug that into our calculator. .8614. Usually what I do at this point is I check. So I can plug this all in at once. 2 times 5 to the power, and I'm just going to use my answer. And then close my parentheses. Not there, though. I got to go down. Plus 1. And I expect this to be a 9. We're good. Sorry, I don't know how to make this bigger.
So when you're checking it,
Mhm.
you're just putting
The number before it. Create that long decimal.
yeah.
And if I were to do that same thing, let me copy. Can I copy and paste? Yeah, and I'm not going to put answer. I'm going to go and erase that, and I'll show you if we put the number that we rounded off to. So if I do 5 power to the 0.8614, like rounded really hard, do you see that's practically 9? Yeah. The reason it's not perfectly 9 is because we chopped our decimal.
So if the x is in the exponent, you can always move it to the front.
As long as there's a log in front. That's like the 1,000% when you guys go forward, when you use logs is to get variables out of the exponents. Yeah. You see that's the same thing as the last problem? Same method, bring the x down, divide. Okay. Everybody good? Were you able to check?
Yep.
Yeah. All right, let's try this next one. So this is why, you know how I showed you guys the 2 methods? This is why I go with the one I go with. That's not like in exponential or logarithmic form, is it? It's weird. 2 powers on both sides. So what we're going to do, same method. Let's take a log of both sides. This problem, you may want to leave some room. It takes a bit of room here. When you bring those powers down, put them in parentheses. Bring them both down like we did in the last problem. Okay. I could, because log 3 is just a number, right? Log 2 is just a number. I could plug them in and get decimals and then carry those decimals the whole time. Or I could try to carry log 3, which is kind of overwhelming. So this is what I do at this point. You don't have to do it, but I feel like it makes it less overwhelming. I'm going to let m be log 3. I'm also going to let n equal log 2. So when I rewrite this, instead of having that big log there, I just have m and n. And it becomes like less overwhelming. If you don't want to do that, that's fine. But that's how I keep it just nice and easy. This method is done the same way every time. We brought our exponents. We replaced our logs with m and n. And then now let's distribute. So on both sides, it distributes. We're solving for x, correct? So I'm going to add 3m to both sides. Oh, I should put that over there. Plus 3m. And then I want to move this negative 3nx to the other side. Okay, so that's gone. That's gone. Okay, so I get mx minus 3nx equals 3m plus n. All we did in that step, get all x's on one side, everything without an x goes on the other.
Wait, how are you adding the 3m to the n?
I'm not. Do you see that? I'm just like putting them next to each other.
Oh, okay.
Yeah. So I'm not combining the like term. All I did is put it there so I could cancel the other ones. I can mark them out. This is where people get stuck. The problem right now is I have 2 x's and I want 1. So what we're going to do you notice that both terms have an x in it? So I'm going to pull the x out. What would be left inside if I factor out x? Perfect. M minus 3n. Now I only have 1x. How do you solve for x?
Divide the...
Absolutely perfect. Yeah. 3m plus n over m minus 3n. But our answer, right, or our problem to begin with didn't have m and n's. So at this point, I go back and replace. So 3 log 3 plus log 2 over log 3 minus 3 log 2. So that's an exact answer. Do you see why I used m and n?
It just makes it easier to write down.
That's it, yeah. And it makes it I don't overwhelm myself. There's a lot going on here, but the good thing is you take any version of this problem, like if I put 5x plus 7 equals 10, 3x minus 2, no matter what I put there, don't write that down, but no matter what I put there, the method is the same. It works out like identical. The powers come down. I change them to m and n. I distribute. I get x's by itself. I divide, factor out and divide. Every time it's like this. All right. Then you got to be careful the way you plug it in. Okay. So is there a fraction button on this? I don't think so. So if you don't have a fraction, you got to use parentheses. 3 log 3. Make sure you close it. Plus log 2, make sure you close it, and then I'm putting another parentheses, that's my numerator, and then I got to divide by the denominator, so I got log 3, close it, minus 3 log 2, close it, close it. You may have a fraction. If you're using one of these, the fraction, you can make it and it looks just like it. I got negative 4.066, if we round, we get 70. Because I would round that 9 up, making it a 69 becomes 70. Hate it? Yeah, just a little bit, yeah. Once you do it, I hate saying this because it's kind of like a duh thing, but once you do it 3 or 4 times, it becomes a straight shot. You'll be just fine. All right, we could check if we wanted to. I guess we're here, might as well do it. So 3 to the, it's going to be the answer, second answer, minus 3. So I'm going to put that in, I'm pushing enter. And then I'm going to do the other side. 2 raised, I use my, oh, it's up there, great. 3 times, okay, I can't use answer now. So what I do is I go up and I just copy it there. So now I have that, and then what was it, +1? And those better be the same. We're good. The top one I could use answer because that was the one right above it, right? But if I were to use answer again, it's going to use the 0.0004. It always uses the last answer as answer. All right? Whatever you need to do, I'll give you a sec. You need to write a note on there or whatever. That is the hardest problem out of this section. All right, the other ones are much more straightforward. I think that phrase makes sense. If it doesn't, I had public ed. Okay, so we have this now. Just a reminder. You see that the bases are the same? They're both e. What do I do if it was like this? X squared times x to the third. That would be x to the fifth. Because when the bases are the same, I take my exponents and add them. So this becomes 3e, and now I am going to add my exponents. So 3 plus -5 is -2x equals 2e. It almost looks base to the power equals a number. The problem is I have that 3. I don't have the exponent on the other side is just a 1, so I'm not going to use that as an exponent. So I'm going to divide by 3. So that puts 2/3 e. Now, I can use the pattern that we did a second ago. I can either change form, that's in base power to number, I can go to p in the log bin, or what I want to do just to help understanding is we're going to take ln of both sides. On the right side is just a number, there are no variables, so I'm just going to leave it like that. And at the very end, we'll plug that into our calculator. Okay, what can I do with the power? There's a log in front of the number now, so it can come down. Do you guys know what ln of e is? It's what?
Is it 10?
So let me rewrite. This is the definition, right? Log base e of e. That's what we're looking for. That's what ln means, is that log base e. So this says e to some power equals e. E to some power is e. What's that power?
Oh, E. Right?
Nope. 1. Right? E to the first is e. Also, if you forget, grab your calculator and plug in ln of e. It will give you a 1. So that means on that left side, this just becomes -2x minus 3 equals ln of 2/3 e. Don't worry about that thing on the right. It's just a number. We're going to plug it in. You don't do anything with it. You're trying to solve for x. What would you guys do first? Yeah. So I'm going to add 3. You can't put them together, but I can write it. -2x equals, and I like my 3 up front because I know for sure it's not inside that ln. You can put it behind too. It doesn't matter. Last step. And 3 plus ln of 2/3 e over -2. Now it's a calculator problem. Just be careful the way you plug it in. Did you guys get -1.7973? if you see one of these problems, like the way it's set up at the beginning, these problems are usually when they give them to you are exactly the same as this problem that I set up for you. It'll have two e's that you put together and add your exponents, and then you use the same pattern. Yeah.
Why did, so 3 up from the solution, why did the ln
I was
go
gonna say
away
that.
on the left side?
So remember, ln of v was equal to, I have a question mark over here. I guess we didn't fill it in.
Because it's equal to 1.
Uh-huh. So if I replace that with 1
It's up.
times 1, right? Yeah. Good question.
Oh, okay.
Yeah. That was on purpose, right? That's why we picked ln, is so that would go to 1.
Okay. The e by itself, what does that mean?
Like on the other side?
Uh,
Or like right here? Like that's e to the first.
Okay.
What e is a number. So like if you go here, second e to the first power and you push enter, that's what e is. 2.71, blah, 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 blah.
Would this be the same problem if it was written like 3x to the 3x?
Almost the same, right? If this was like, you're saying if those were different numbers, right?
Yes, yeah.
Yeah, you do the same, except for instead of using an ln, you use log, base 10. I only use this ln when I have the e. Otherwise, you're going to use base 10. Yeah. Because let me give you a problem like that. If I had like 2 to the 3x minus 2 times 2 to the negative 5x equals 2e, you'd approach it the same way. 3 times 2, and then you'd add your negative exponents. And you got 2e, and then you would do 2/3 e, just like we did, right? And then at that point, you would take a log base 10 of both sides instead of ln.
Okay.
And then this looks like the problem we did. The very first problem, they're identical, but different. Like the exponent's worse than the first problem, but the method is the same.
So the e's are not, it's not like if it would be p or b or x, it's not a variable.
No.
E is its own.
It is its own number. Yeah, and we kind of talked about it in passing, and it comes from the interest formula. Do you guys remember seeing this compound interest formula? Euler, spelled like this, worked on this. If I put $1 in at 100%,
Okay.
1 year, he found that if you just let n get bigger and bigger and bigger, that thing approaches the e number. He just kind of fell into it. And then it's crazy because this e number is like everywhere in nature. So it's very, very powerful. The crazy thing, the things that happen in math and the like coincidences are insane. I won't go too far down that nerdy trail. But the things we find in nature and how they line up to our mathematics is pretty insane. So have you guys ever heard of the golden ratio? There's like a golden ratio, and the Greeks used it to like describe our bodies. But the way bees reproduce in nature follows that ratio. And then there's several other things. Have you guys ever heard of the Fibonacci sequence? I'll do one more and then I'll go back to topic, okay? The Fibonacci sequence is 1, 1, 2, 3, 5, 8, 13. Do you guys know what the pattern is?
You're like adding
Is it double?
previous?
Yeah. You add the previous 2, and you get the next number, right? 1 and 1 make, that's the next number. 1 and 2 make, 3, that's the next number. You seen it?
Yeah.
2 and 3 make 5. This is called the Fibonacci sequence. Obviously, like you can make up that pattern right now, right? It's just like an easy pattern. The further you go into that pattern, you go up and up, and you take one number and you divide it by the number before it. The further you go out, that division problem gets close to the golden ratio. Why? Why is that there? Like that's just a number pattern, right? That had nothing to do with nature. We're just picking a pattern and going with it. But for some reason, that golden ratio is in there. Right? So that's why I love math, is that weird stuff. But unfortunately, with the way we approach math, we don't do anything fun until you're going to go to school for math. So, okay, I'll get off the nerdy trail there.
Did
Pretty-
you write how you wrote that in the calculator? Because for me, I'm getting like 2.7 instead of what you got.
Anybody, did you guys get negative? Has anybody tried to plug it in?
I didn't.
Okay, try to plug it in. I'm going to re-plug it in or reconsider. I'm pretty confident in the way I plugged it in. Do you still have it there?
You did it right. Yeah, I do.
I mess up all the time. My top 3 lesson yesterday was horrible.
I was like, cause you put it like e to the first, it looks like it's so small.
Yeah, it is e to the first. Yeah, I can't make that any bigger.
And I was like, mine.
It's like identical. You plugged it in the exact same way.
Do I, when I plug in the E, do I just put one E to the?
E to the first
Okay.
What is happening.
I also tried to plug in the other ones that you did, and I also did.
You're not getting the right answer. Something's up with your calculator.
Okay.
Do you have any? Nope. I'm gonna reset it for you.
Go ahead.
Cool.
I was like, it's my brother's, and he's an engineer, so I'm
I
sure
don't-
he's done something to it.
Right. They put weird programs on it.
Yeah.
Okay, I'll plug it in. 3 plus ln of 2 divided by 3, e to the first. Close that. Close that. That's what it is.
You get it?
You needed it, we didn't need to reset. Look at my parentheses there. You forgot to put an extra set of parentheses after your 1.
Got it.
Yeah. Because you closed off the e, you closed off the ln, but you didn't close off the 3
The
plus.
3.
Yep. Yep. All right. Let's go on. These are much easier. This is where everything speeds up. Did you get it? Did it work out? Let me check.
Sure you can look up.
Okay, when you write these, you have to like put, I'm like putting the whole denominator in parentheses.
Okay, I thought I might have been that bad.
Yeah, so you close that closed ln. This is my whole numerator and closed in parentheses. You see, I started my open. I opened it with before 3, and then I closed that parentheses at the very end.
Okay,
And then then you divide by your -2.
okay.
Or you could type in the numerator, push enter, and then take that answer and divide it by -2. And then you won't make that mistake.
Okay.
Yep. All right, take a look here. These are done by the pattern. Remember our pattern? I'll write it again. Base to a power equals a number. And then the equivalent is p in the log bin. All right, those are our 2 forms. All 3 of these are in logarithmic form, right? The p in the log bin. So all I got to do is change it to the other form. What's my base in the first problem? X. What's the power? Careful. 3. And that equals 27. Do you remember our pattern that we came up with the other day? This to that power is this number. It's always like that. Okay, so all you're doing now, if I want to solve, and maybe you guys could eyeball it, but if not, we're just taking the cube root of 27. You guys know what that is? Try plugging it in.
3.
Mm-hmm. Because 3 times 3 is 9, times 3 is 27. Isn't that much easier than all the other problems that we've done? That second example. Can you guys set up an equation following the pattern? Yeah.
So you don't have to worry about the log. in the-
You change to the form and gets rid of it.
Cool.
Yep. So that means x is 25. We're done. It all comes down to, do you know the pattern? If you don't know the pattern, you can imagine how you can't do anything to this to answer it, right? You can't add 3 to both sides or divide or anything. You have to know the other form. All right?
So I remember you telling us that the quadratic formula, like memorize that, is the p and the log bin something you should
Yes.
include to the
Yeah.
ILIS?
Most people struggle with logs. So most of my calculus students. So if you can be good at it, yeah, you'll be set. The big thing that gets people for calculus is that quadratics, like factoring and the formula. That's what gets a lot of people. And you got to be able to, the graphing of a line, that doesn't go away. You keep doing that till like diffie q. So, okay, follow the pattern. Can you guys tell me what to write?
To the 1/3 equals x plus 2.
Perfect. Do you remember what 1/3 power is?
-3.
Not negative. You're okay.
It's like, when you, like, I think you, cube rooted.
Yeah, 1/3 means cube root. Yeah, because 1/2 is square root, right? 1/3 is cube root, and you just go up. 1/5 is fifth root. So you're just going to take the cube root of 8, which is 2, right? 2 times 2 times 2 is 8. And then our last step, -3. As long as you know the pattern, these are very easy equations. But there's no BSing. You're not going to accidentally find the answer. Better than the others? Yeah. Okay, they're going to get a little more complicated, but they're still going to be nowhere near the difficulty of the first couple that we started. Bless you.
Thank you.
Everybody good on that page? Yeah. All right, let's try the next one. Everything's going to come down to that pattern. How do I write an equation here?
2 to the 3rd equals.
That mess, right?
Yep.
Yeah, I won't make you say it. It gets rid of the log. That's the whole point. You guys just did 2 to the 3rd. 2 to the 3rd is 8. How do I,
You need to combine those.
yeah, how?
Factor.
Opposite of factoring.
Foil
You're right.
box.
Foil box, multiply it out. Yeah, I know what you meant. So I'll do this for you if you would like, or you can try it if you want. Remember, our end goal for those of you that are doing STEM is to be able to do that like what I just did. No box, no lines, just write it down. Eventually, right? I don't think I could do it till I was done with calculus because we force you to do it a bunch. All of you guys had to do Calc 1? Have to go up there? What was your degree?
Mine?
Yeah.
Pre-veterinary medicine.
So do you know if you had to take Calc 1?
I think so.
Yeah, it sounds like that would go through. What is your degree?
I was doing biomedical engineering, but I'm switching to radiology tech.
Are you done then with math after this?
I don't know.
Okay.
I think I might have one more. but-
Okay, you may have to take trig, so pre-calc 2. Computer science, right? No, business, sorry.
You're good.
The person before you this morning is,
Yeah.
yeah, computer science.
So I don't have to do that.
You're done with this after that. And you're engineering, right? Pre-engineering? Cool.
Mechanical, I'm definitely.
Yeah, you have to go through it all. And then you won't use any of this as a mechanical engineer.
I do have accounting.
Okay, yeah.
That's
Totally different. My mom's an accountant and she can't do math. So, great, this is recorded. All right, so she won't see it. This is a quadratic, so to solve it, I got to get everything onto one side. I have two options here. I can either factor, which it does, and that's what we're going to do. What if I didn't want to factor? What could I do? Quadratic formula. We don't need to do the box in x. Since there's an x squared, I can just put xx. And then now I'm just trying to find two numbers that multiply to this number and add to that number. Multiplies to -18, adds to 3. Perfect. Which one's negative? 3. You're good, yep. We want a positive coming out, right? So we got two answers here, -6 and 3. Here's the deal. You remember when we were doing rational equations and you'd solve and we just had to make sure it didn't make our denominator 0? We were doing that. We didn't care about getting a number and checking. We just cared about that it wasn't making it 0. Kind of the same thing here. So when I take a log, I'm going to write a note here. Log base, whatever you want, I'm going to put a 2. Must be positive. That includes 0. It can't be 0. So when you get answers, you have to make sure that you're not going to take the log of a negative. I don't care what it comes out to be. You could go that far and check. but I'm just making sure I don't make that mistake. So if I plug -6, all we're looking at is right here, right? That's the inside of my log. So all I have to do is make sure when I plug in both x's, what I've highlighted there doesn't become negative or 0. So if I plug in -6, I get a -1 there, and I get a -8. It's going to be positive, isn't it? -1 times -8 is a positive 8. We're good. So -6 is an answer, potentially. We didn't check, but we solved. Adding 3, I get an 8 and a 1. We're good. So both answers are great. If you were to plug it in and get like a negative or a 0 inside, you just mark out that answer. We have one coming up.
Wait, so you have to like switch through and see which X is supposed to be in which spot?
No, when you plug, like if I was checking -6,
Yeah.
I'm going to plug -6 into both.
Oh, okay.
And just make sure, we want to make sure that what I've highlighted up there inside that log, when I plug in -6 into both, I better get a positive.
Okay.
Or if I plug in 3 into both, I better also get a positive. If I plug in one of those numbers and I get a 0 or negative, you just mark it out. Can't be that answer. You're about to see that.
Is that always like that?
Yes.
So log to any base cannot have a negative. at
Can't
all.
have a negative or 0. If you're unsure, grab your calculator and try to do log of 0, and it won't come out. It'll say error. So if you forget, just start playing with the numbers. All right. All right. What's different about example 7 compared to the ones we've done?
There's 2 logs.
2 logs. So what would our goal be then? To get 1 log, right? Because if I get 1 log, then it just becomes the problems that we were doing. Do you guys remember what we can do when I have 2 logs that have the same base and there's a plus sign in between? Yeah. We have log base 4 of x times x minus 6. That's what we did last week, right? If I have a plus sign with the same base, I can put them as 1 and multiply my answers. That came from the lesson. Remember, I gave you guys a lesson last week that was 1 sheet of paper? That's that section.
So, how do you write that they're been multiplied together?
I just put it like that.
Okay. Well, I mean, like, you just took out one of the logs.
It looks like one.
It looks like I took one out, right? But the property says that when I have 2 logs that are the same and the numbers inside are different, I can put them
Oh.
together and multiply.
Yeah, I see it now.
Cool.
I don't know.
You're okay. It's Thanksgiving break.
Yeah.
We're all tired.
Yes, I'm very tired. So my weekend was stupid. All right. Pattern, right? What's the pattern here? What do I write? Don't let this, you guys maybe are letting this trip you up. That's its own thing. What is it? 4, 2, and then all that. Don't let all that thing inside what I highlighted bother you. It's one term. We got rid of the log. Now it's just going to be a quadratic.
Oh, is that changing its form? Is that what you were doing?
Yeah, exactly. I usually, when I start with the log, I don't think forms. I just do the pattern. Yeah. All right, so it's quadratic, so I got to get everything on one side, and 0 on the other. And then at this point, we can either factor or use the quadratic formula. I'm going to go with factoring because I know it factors. We did it earlier. 2 numbers that multiply to multiply to -16 and add to -6. Perfect. What are the signs?
8's negative.
Mm-hmm. 2's positive. Now we can use 0 product property. We got 8, -2. Right, you have to go back to the original problem and consider plugging things in. So my first answer is an 8, right? So I need to plug an 8 right there and plug an 8 right there. So for this one, It's definitely positive, right? It's an 8, log base 4 of 8. If I plug 8 into here, 8 minus 6 is 2. I think that's probably good. Okay, the next thing I have to do is plug in that negative 2. And it dies right here. Right there at that x. If I plug in negative 2, I get log base 4 of negative 2. That's a problem. So I just mark it out. It wouldn't have worked in the other one either, right? Negative 2 minus 6 is negative 8. So you have to think about, what if I plug it back in? If I get a negative with the log, inside the log, that answer doesn't count. It's not going to work. If you try to do, like, I'm going to show you. If we do the like bases, so I could do like log of negative 2 divided by log of 4. That's what that would be, right? And it's just going to say no non-real answer or error. I don't know what yours will say. But if you're checking, you'll figure it out, right? You'll run into the wrong answer.
So you really don't have to plug it all in and make sure that it all equals 2 like the original problem.
No, I'm not.
It's not negative.
If you have time,
You can.
you should. Yeah, right. I usually save that for my end. If I get done with everything, then I go back and check. But I'm careful because I am one of those people that get the right answer first and then doubt myself and change it and miss it. So I'm just aware of that. So I got to be careful. But yeah, it's just like, remember we did the rational functions with the x's on the bottom? And we didn't check to see if the answer was right. We just make sure our bottoms weren't 0. Kind of the same thing.
Okay.
Yeah. All right. Are we good on that one? Any other questions? We have tons of time, so I'm trying to go slow. This morning I felt like I went super quick. In calculus, those quadratics are going to keep popping up. Pre-calc 2, the quadratics end up looking like this.
So,
Yeah, go ahead.
the negative inside the parentheses, that means it's not real numbers or something?
Yeah, not in parentheses, but like right here. Do you see where I'm circling? It up here. Yeah, if I take that, let me move all those. Come on. If I take that and I try to do log base 4 of a negative number, it's not going to work. That's when remember, we can't do those in our calculator unless we split them like this.
Yeah, I understand.
Yeah.
Just want to make sure that it's just mean like not real numbers.
Yep.
Okay.
That's exactly it. Yep.
How did -6 work?
Negative 6 works if on that last problem is because when we plug it in, it's a good question. When we plug it in up here for this part, okay, let's think about plugging in negative 6. Okay, if I plug negative 6 plus 5, I get a negative 1. If I do negative 6 minus 2, I get a negative 8. And then when I multiply them, I get a positive. Yeah. So it can be a negative answer. That's fine.
As long as it doesn't come out negative.
Exactly.
Inside the log.
Inside the log. Yep. Cool? All right, we're going to make it a little more complicated. I think we have 2 more here and then a word problem. The word problems involving log are so easy. I get people, though, on my test, if I give an application like that, they just skip it because it's a word problem, and it takes 2 steps. It's, like, really easy, but people don't do it. Okay, this one, what's different about this problem? I do have 2 logs on the left, like last time, and then I have
Log on the right.
log on the right.
There's base 10.
All base 10, so that's good. They got to all be the same. What can I do with these 2?
And combine.
Combine them, and since I'm adding, it is going to become multiplying. Yeah, very good. So I get 4 times 4x plus 1, and that equals log base 10 of 15x plus 5.
So if it was a subtraction, you would have it dividing, so log 4 divided by.
4 over 4x plus 1. Take a look at the next problem. There's a minus. We'll deal with it. Yep.
Okay. We'll
Cool.
go next.
Yep. Try not to leave you hanging.
We'll get there.
Yep. So one thing I want you to think about here, and then I got to point out, you can think something. Let me just explain. Okay, I have log of A equals log of b. What's the relationship between a and b?
The log?
They have to be equal as well. When I have logarithms,
Oh,
they like, yeah, you're good. The thing about logarithms, when I plug in numbers, they never give me a repeat. Like if I plug in 3 into a log and I plug in 5, those answers are different. So if that's the case, using this, what we just wrote down, then I can just drop my logs. We're not dividing by log. We're not canceling log. We just know that if two logs are equal, the arguments, the insides, have to be equal. If you want to think in your head, divide by log, sure, but that's not what you're doing, right? LOG is just a word by itself. You got to have something after it to make sense in math. Okay, so now I'm going to distribute. This is just a like 3-step linear equation. I'm going to make a jump here, see if you're good. Get the same thing? Minus 15 gets me a 1x, right? And then if I minus 4 on both sides, that gets me a 1 on the right side. Is that answer going to work? 4 is 4, so we're good there. If I plug 1 in there, it's positive. If I plug 1 in there, it's also positive. We're good. It's probably right. All right. Let's get to our division now. So notice the minus. And you already said what that does. So the log base, we'll have log base 5. One thing you have to make note, and I move quick when I do these, is those have to be the same. 5 and 5 have to be the same to use this property. So if they throw you different numbers, you're stuck. You're not going to be able to do it. I'm not really telling you that for this class because you're not going to see it in here. But moving forward, I don't know what you're going to see in your fields. My degree's in math, not engineering, not the other things you guys said. Biological. Anytime somebody says not math, I'm just like, okay, cool, whatever that is. You're going to make more money than I am. That's what that means.
So we won't see it on our homework where it'll be.
Different, no. The problem changes pretty dramatically if that's the case. And it gets much more difficult. All right, I got x squared minus 9 over x plus 3 equals 2. Use the pattern. 5 to the second equals all of that. I'm going to change my 5 squared to a 25. What would you guys do from here? What's the problem spot right now? Because we're trying to solve for x, correct? Trying to get x by itself or some kind of quadratic. But the issue right now is I have...
multiply 3, x plus 3.
Yeah, the problem is in the bottom, right? I really don't want that x plus 3 to be there. So I'm going to multiply that side by x plus 3, which tells me I got to do the other side because of equality. The reason we do that is because now those x plus 3s are gone. I got it out of the denominator, or you guys did. Dustin did. So I distribute the 3 on that next line. It's a quadratic, surprise. That's going to happen a lot. Since it's a quadratic, I know to get everything on one side. So 0 equals, sorry for that, x squared minus 25x, and then minus 74, I think that's minus 84. Sorry, minus 75 minus 9 is negative 84. This thing factors, believe it or not. Okay, first thing, 84 is divisible by 2, right? But that'd be 2 and 42. Doesn't work. Is 84 divisible by 3? Do you guys know how to check really quick? I'm going to show you. 123 is divisible by 3, I know right away. How I tell is I just add my each number up. So what's 1 plus 2 plus 3? If that number is divisible by 3, the big number is divisible by 3. So if I put the number 1, 2, 3, 4, 5, 6, is that number divisible by 3?
Yes.
Yeah, I got 21 adding them up. Since 21 is divisible by 3, that number is divisible by 3. That works for 3 and 9 only. No other numbers can do that. 3 and 9. All right. So knowing that, is 84 divisible by 3? Yeah, 8 plus 4 is 12. 12 is divisible by 3. So that actually ends up being it. It's 3 times 28. Minus with the 28. All right. Zero to product property gives me negative 3 and 28. So I just got to check now. Is that going to make anything 0 or negative up top? So I'm just looking inside the parentheses. So if I plug in 3 right there, or negative 3, it's going to make a 0, isn't it? Yeah, so mark out that negative 3. Is 28 going to work? 28 squared is huge, right?
Yeah.
Minus 9, still going to be positive.
Yeah.
And then if I add a positive to a positive, it's positive. We're good. So 28 only. Are you guys understanding how to check? Okay. We got one more. It's going to be an application. And like I said, those of you moving forward, since it's our last section, those of you moving forward in math, usually the word problems are the easier ones because I have more information, right? The more information they give me, if they give me 2 paragraphs, I'm happy because I can read it and I get a lot of info. You know what problems scare me? When they're like 5 words. And they say, do this. No other information is given. So when you see paragraphs, I have students that straight up just skip those problems. They don't even read the paragraphs. You should at least read it because usually it's pretty easy. Okay, let's take a look at this. Logarithms, where they're important, where we use them quite a bit in real applications, is substances in our body. Or leaving our body. So if you were to take an ibuprofen, right, or something like that, the way it leaves your body is logarithmic. So logarithmic, you remember it like the graph looks like this? So it's like very like powerful at the end, but it's not going to look like that when I do it. It's going to look like this. It flipped over.
Bloodstream?
In your bloodstream.
Like just the way how like it moves in the body, or
How much is in the body. So it's like, you know how you measure a substance with how much it's in your bloodstream? I'm talking way above my head. I don't really know what I'm talking about right here. But you know how it's in your body, and then over time it leaves your body?
yeah.
It works in like an exponential logarithmic manner. If you take a look at this, like you would have so much drugs in your system, and then over time, it just goes out. It gets to a point where you can't see it anymore.
It like never goes out.
It never hits the.
Technically.
Okay. There's always a little bit of something.
The problem is with that is when we like do model in math, is our functions aren't totally accurate to what the world works like. For instance, you know, like in this class we talked about things flying through the air, and you would figure out where it lands or the highest point. That's not how that stuff works. There's air resistance, right? There's gravity. If you're rolling something on the ground, in math we ignore friction. Do you see what I'm saying?
Yeah.
So even though we're representing it with a log function, does that mean that substance is going to stay in you? No. But the model we use kind of models that, right? It's going to go away really slowly, and then eventually it's gone. Make sense?
Yep.
Yeah. So you'll do a lot of models, and especially those of you that aren't going to go very far in math, the models will never really be accurate until you get up there and we start adding all that stuff in. Cool. Okay, the pH of a substance is pH. I'm going to write this down. This is my equation. pH is a variable, one variable. pH equals negative log And then I'm going to put the base there. What is it? If it's not there, it's 10. And then this is weird. This is where it trips students up. H3O positive is a variable. The whole thing is one variable. They want to know what is H3O positive for a substance with a pH of 5.3. So I'm going to fill in pH with 5.3. I'm going to keep my 10 there just to remind me. Now, it's very tempting to go to the pattern right away, right? But there's something that keeps me from using the pattern.
Is it the negative?
It is the negative. I just got to get it moved. So I'm going to multiply both sides by negative. Now, I can use the pattern. You can only use that pattern if there's nothing in front of log at all. So the pattern here, 10 to, what's the power?
-5.
Yep, negative 5.3, and that equals H3O positive. Remember, that thing is its variable in itself. We're done.
Oh, that makes sense.
Yeah, and you just plug that in your calculator if you want a decimal. It's going to be very small. You see what I'm meaning? Applications typically are very straightforward. A lot of these applications, they're literally just going to have you plug in something for H3O, and then you just evaluate your log.
So the H3O is just kind of there to throw us off?
I don't think it's there to throw you off. I think that's just how they describe the variable. Because it's a compound, right? H3O positive makes hydronium ion concentration. I don't even know what that is. But it makes some, H3O is something like H2O is something, right? H2O is water. Yeah.
Hydrogen's one oxygen positive.
And I don't know what the positive means. I'm not a chemist.
I don't even.
If you guys have taken chem already, you're already ahead of me. I didn't take chem in college. So, yeah. Is that okay?
Yeah.
I feel like you guys, the problems are going to look like these. That's what's really great. This is one of those sections, you'll pull up your homework problem, then you just go look at your notes, and you should be able to find one that looks like the homework problem. All right. I will send an email out, but I'm going to say it since we're on video, if anybody will watch this, I hope. Next week, we're done, right, with content. That's it. We're just going to prep for our final. So next week, what I'm going to do is we're not going to hold a class. I'm not going to come in here. I'm going to be in the tutoring lab like all day. So like on Tuesday, Thursday of next week, I will be in the tutoring lab from 8 to 4. So you can come in anytime to get help on your review. If you don't need help, then I'll see you on the final day. Okay?
And final day is
Final day is Thursday, is that the 12th? Check on Blackboard. If you go to Blackboard schedule, I tell you exactly when the final is. They may move the time. I need you to make sure that, because all classes become, instead of an hour 20, they're 2 hours. So that means the schedule's going to shift some. So I'm guessing this test is going to be at 10. Sorry, no, we start at 11, don't we?
Yeah.
It probably won't change then. All your 30s will probably change. All right, guys, reach out to me if you need help. This next week, I'm going to be extremely bored. So please come get help.
We're gonna do the finals in this room?
Yes.
Okay.
So final will be in here. I'll send out an email to remind.
Is it computer